Hello everyone and welcome to this online tech talk on exploring CDKs, CDK for Kubernetes. My name is Pavan Mistry and I'm a senior developer advocate with the AWS Container Services team. I worked in AWS previously as a specialist solutions architect and as a manager within AWS security. Prior to AWS, I worked as a security consulting leader at global enterprises. You have my email address and Twitter on this slide, so feel free to contact me for any questions on CDK, CDKs, AWS Container Services, or security in general. So this is a level 300 tech talk, so basically understanding of AWS services like Amazon EKS and AWS CloudFormation is expected. First, we'll quickly understand the fundamentals around AWS CDK in the context of Amazon EKS or Amazon Elastic Kubernetes Service. Next, we'll do a deep dive into the CDKs project, followed by an overview of CDKs Plus package. And at the end, we'll use this feature in action to build a simple app within the EKS cluster using just a few lines of code with CDK, CDKs, and CDKs Plus. The talk is structured such that you'll easily be able to reproduce code and get hands-on with these tools. The goal of the tech talk is to leave you with an understanding of CDK, CDKs, and CDKs Plus, and how you can work with these tools to improve your operations and build workflows for deploying Kubernetes applications. We'll end the tech talk with a Q&A session. So before we get started and actually dive in, we are making some assumptions. One, that there is a high level understanding of containers and Kubernetes in general, specifically what a container image is and how to work with container images, Kubernetes YAML, and so on and so forth. We'll also assume a basic understanding of working with AWS Console and AWS services like AWS CloudFormation and Amazon EKS. So CDK or Cloud Development Kit and Amazon EKS. Let's take a look at the evolution of the tooling and processes in infrastructure provisioning. It probably started with manual deployments where we used wikis and playbooks which sometimes were outdated. I'm sure most of us can relate to some of the projects where we had to use it. The next step was scripting everything in Bash. It had worked until the complexity was too big because Bash is not built for creating complex deployment frameworks, so it was hard to maintain. An important next step was the introduction of infrastructure provision engines such as AWS CloudFormation or Terraform and others. These tools would hide the complexity of state management, rollbacks, drift detection, error management, and so on and so forth. Many companies and developer communities adopted the new infrastructure as code way, and the adoption increased rapidly. And this led to growing size of templates which were hard to maintain in JSON or YAML format. So the next idea was to use generators, write code that generates JSON or YAML document from classes and methods of programming language. And on top of that idea, new tools emerged such as AWS CDK or Pulumi, which provides tools and framework to create custom abstractions for cloud infrastructure. So AWS CDK or AWS Cloud Development Kit is an open source software development framework to model and provision your cloud application resources using familiar programming languages. You can do this in different programming languages such as Python, JavaScript, TypeScript, Java, or C#. Golang is coming soon to CDK. So with CDK, you could be much faster than with previous tools because you work with your familiar language and concepts, classes, and method without switching context. You also have all the tool support from the programming language such as autocomplete, inline documentation, tests, linting, and debugging. And an important part is that you are able to build your abstractions and components of the infrastructure and application. So there are three main components of CDK: the core framework, the AWS construct library, and the command line interface. With the core framework, you can create and structure apps that contain one or multiple stacks. Stacks are logical units of infrastructure which contains multiple resources and mapped one-to-one to CloudFormation stacks. It is a good practice to divide resources into stacks that have different life cycles. That is, you would create one stack for network infrastructure such as VPC, another stack would have an elastic Kubernetes service cluster, and yet another stack would be the application that is running in this cluster. We'll actually demo this at the end of this talk, so stay tuned. The AWS Construct library is a set of components crafted by AWS to create resources for specific service. This helps to decouple libraries and use only the dependencies that you need in your project. It is also built with best practices and security considerations to provide good developer experience, ease of use, and fast iteration cycles. The CDK CLI helps to interact with the core framework to initialize project structure, inspect differences between deployments, and deploy easily to AWS. We start our project by executing CDK init that will generate a project structure for our specific programming language, and we can start creating our app, add stacks, constructs, and resources. Once we are done, we have to build the project. That is, if we use TypeScript, we use the command npm run build. Then we need to synthesize our code to CloudFormation template. We run CDK synth, and this will generate CloudFormation templates and assets, and we call this bundle Cloud Assembly. Before we deploy, we can inspect what we change if we deploy this Cloud Assembly, which resources will be deleted, updated, or created. So with CDK deploy, we push the changes to the AWS CloudFormation service, and from there, the service will create cloud resources in our AWS account. So let's get hands-on with CDK and use CDK to provision an EKS cluster from scratch. Okay, so here we are in the terminal, and I'm just checking the AWS version and the CDK version installed within my CLI. You can do an npm install CDK to install CDK. CDK Doctor allows you to look at the configuration within your terminal or your laptop. And I'm just creating a directory which allows you to create your app. And then once we are in the directory, I'll do a CDK init language TypeScript. This installs all the boilerplate that you'd need for your application. And once we have that installed, we'll open up the code which allows us to view the boilerplate, which was created by CDK. So taking a look at the package.json, which includes all the dependencies that were installed by default, we have a few installed already, but to create an EKS cluster, we'll need a few more. The starting point of the app is within bin, and the lib has a TypeScript file, which is your entry point to the code. So that's the one we will edit. But before we do that, we'll just run npm run build, which will build our code. Obviously, we don't have anything in the code yet, so when we do an CDK synth to synthesize the CloudFormation, it will create a default CloudFormation script which doesn't create any resources for you. So now we'll go ahead and install the libraries that we need, one of which is most important, which is around EKS, but we'll also include CDKs and CDKs plus because we'll use that later on, and constructs. So once that's installed, we'll take a look at the package.json file again, and that has all the dependencies installed. And now we can add that into our code. So we do an import star as EKS from the AWS CDK EKS library. And then just use that library to create the cluster, a new EKS cluster with the construct scope and the name of the cluster, which you can pass on here, and then the props. And one of the props you need is version. So we'll create the version of the Kubernetes that we need, and We specify that through Kubernetes version, and we recently announced version 1.18 support. So we'll create that. So an npm run build builds the code, compiles it, and then synth will show us the actual CloudFormation template, which has all the resources that you'd need to build an EKS cluster. So this is how easy it is to use CDK and create an EKS cluster using CDK. You can switch versions and add a lot more. We'll look into that as well. And now I'm doing a CDK deploy, which lets us review the security related changes. And once I say yes, it's going to create the CloudFormation change set and run and deploy that into CloudFormation. So let's take a quick look at my console and at the AWS console, and we don't have any clusters yet, but the service I'm interested in is CloudFormation, so I'm going to click and find out what's happening within. And here we can see the creation in process, and we have a few events that are kicked off and some resources which are being created. So this creates your I think there's you have to wait for a few minutes, but once it's created, it will let us view the cluster by running kubectl commands and adding it to your kube config. So the expected output, as you can see on the screen now, that once it's created, it gives us two commands. One is the config command, which you can use to update your kube config on your local machine, and that will add the context, and you can switch the context. It switches the context, and to verify that you have the context, I'll be running like kubectl get nodes. And by default, without specifying any nodes, you have two M5 large EC2 instances running version 1.18 provisioned with Amazon Linux 2. So we have that up and running now. So we have a cluster up and running with just one line of code, as you can see, and we're going to use the GitHub command line tool to create a repository, which will allow us to include that change version and versioning around using CDK, which is quite native to developers. So I think this is the cool benefit of using something like CDK against EKS control, which is a command line tool we recommend to create EKS clusters. However, with EKS control, you don't have that general purpose language experience, and you don't have that experience that developers are used to. So this allows you to follow the Git workflow, your GitHub workflow, and what I'm doing here is committing the code out to a new repository and pushing it out to this repository. By the way, this repository will be available for your references. Again, on GitHub, it's a public repository, so you'd be able to refer to it. So now that we have pushed our code, we can take a look at the documentation. So the CDK constructs within for EKS allows you to add different profiles like Fargate profiles and really specify and change your cluster provisioning. So in this case, I'm just copying a cluster sort of Fargate profile, adding a Fargate profile along with the managed nodes which have been added. So I can just reference that, add the profile, and see what changes are happening. So the one way to do it is, again, run the build, and that would compile the code, and CDK synth will show us what additional CloudFormation stacks or resources have been added. And actually, there is a different command, which CDK diff, which allows you to look at the changes between the two versions. And here you can see that we have Fargate profile, which has been added. So the ones highlighted in green is the additions, which are the differences to the previous CloudFormation stack. So actually, we are not going to sort of commit this and deploy this. We are going to revert back to what we had, which is the 2 instances, and just run with that to keep it simple. So I'm going to run the build again just to make sure we have the CloudFormation without any changes. If I do a CDK diff, I should expect no changes to the CloudFormation stack. So that's great. And what I can do is, again, assuming that you have a few developers responsible for your CDK cluster or an EKS cluster, using CDK, you can manage the life cycle of that cluster using a mechanism around Git, and have branches added and have a workflow around the change process, so that there is that rigorous sort of governance around how you are managing your Kubernetes cluster, which can be useful in terms of operating in a regulated environment where you need to demonstrate the workflows and the change processes to your internal audit teams or external auditors as well. So in this case, we are just showcasing how to use GitHub features and create a PR to manage the code which has been added. So really, a CI/CD workflow can be folded around this so that you can manage the code and the version lifecycle within your CDK project. So I'm just adding a GitHub PR review and reviewing that and merging the code so that I can see that there has been a request to add a Fargate profile, and I'll delete the local branch. So you can see those changes up in the repository when you refer to that repository, as I've shown on the screen. So for the app, you can see that there has been a few historical commits and changes to that cluster, and using your commits, you can add the governance around how the cluster has been managed. So now that we have a cluster running, let's look into CDKs. We launched CDKs or CDK for Kubernetes in mid-May. Elad and Nathan wrote a launch blog that introduced the open source project that lets you use programming languages like TypeScript, Python, and now Java to generate standard Kubernetes YAML. There's 3 important things that I think CDKs helps customers with. First of all, CDKs is a software framework that lets you go from code to config. So using CDKs, you can define Kubernetes apps and architectures using familiar programming languages and generate well-formatted YAML for your applications every time. This lets you effectively reduce or completely eliminate the need to copy and paste a template to do what a lot of folks refer to as YAML engineering. Using Kubernetes CDKs, you can turn the best practices for how you define Kubernetes clusters and apps into code libraries, and share them easily with your teammates across your organization or in the larger community. So we think this is a really powerful way that people will be able to share different paradigms and best practices for their Kubernetes clusters. And then finally, we think this is a really important point that CDKs is projects that started by AWS, but it's not for AWS. So CDKs for everyone. It runs locally and it generates Kubernetes YAML that you can deploy to any cluster anywhere. And this lets you standardize across on-premises or any cloud. So let's talk a little bit about YAML. And we use YAML everywhere in our lives, like Kubernetes uses YAML. It is the data configuration and definition layer for Kubernetes clusters. So using YAML is tried and true for us. YAML is great because it's easy for humans. It's easy for humans to read and to understand and to use it in a simple way. So it's universal, so you can use YAML for almost every system for declarative state, and it does a great job of being declarative, of representing the desired state of the system. And that's part of the reason why we all like it as a part of Kubernetes. We can represent the desired state of the system and then use a state machine within Kubernetes to actually bring that system to the desired state. So YAML is also very static. So YAML is very easy when you have a few things to declare. So if you have a simple web app or a few services on a cluster, maybe setting up a config map YAML is very straightforward. It's easy to open a text editor and just type the code. But as you grow, as you start to run lots of app on your cluster and use Kubernetes across in your organization, YAML can get really hard. And we also see this when the job of defining and managing apps in Kubernetes gets passed down from ops to dev. So when developers start taking over management of clusters, they have to do a lot of things that is not necessarily intuitive to them in the way that they write code. So they have to do a lot of boilerplate, and it means that it's manual with a lot of copy and paste, either from a community repository or from inside your company. And it's fundamentally not solving the issue. And that's where general programming languages come in. So they are what developers are writing, so they're familiar with them. And in Kubernetes community, there's a lot of people writing and very familiar with Golang, and in data science community, there are people familiar with Python. And these languages are also imperative, which means that traditionally they're not great for defining the state of a system, but they are really good for defining business logic and complex dynamic applications that we need to write. It's a lot of great tooling and things that you can do with general purpose languages that you can't necessarily do in declarative YAML. And that's where CDKs comes in. The CDK for Kubernetes kind of bridges imperative languages with declarative YAML. And so one of the criticisms is that there are ways to use imperative language on Kubernetes today. So for example, you can write custom controllers in Go that directly call the Kubernetes API, but that actually is harder for most people to implement because you have to own the state machine, and it's hard to find state in a complex system like Kubernetes. The established community tooling for defining state and maintaining state, like kubectl, for example, are very good at holding the state within the system and bringing that state to a desired place. And so re-implementing that logic as a developer actually is really daunting unless you are an expert. And the reality is many people using Kubernetes and developers are less familiar with Kubernetes, and this is a daunting task for them to take on if they just want to get advantage of imperative language definition. So CDKs can give you both, and it simplifies the writing process and allows you to produce best practice YAML for configuring your clusters and applications. Let's go ahead and actually see it in action, because this is the best way to get a feel of how it works. So in this demo, to give you an overview, we'll be creating what is referred to as a chart, which is basically the codified application architecture in the language of your choice. In this case, we'll use TypeScript. Within this chart, we'll include a couple of basic constructs for deployment and a service. So let's take a look. Okay, so let me create a new directory for CDK's app, which is separate from the CDK EKS cluster that we created, and go into that directory. And what we do is similar to CDK. We have CDK init TypeScript, and it creates a boilerplate for us for the actual CDK's project. So here we'll just close that CDK EKS app, but we have the CDK app open now with the boilerplate, and it includes an import of the Kubernetes TypeScript, so the library, and it has all the constructs within the Kubernetes library for us to import, and we'll do that soon. In the main.typescript file, that's the one you'd add it, and I'm just going to add a label, pod info to it, and exactly as you define your structure within YAML, we will use those constructs from Kubernetes that has automatically sort of imported the deployment construct, and that has a spec which we'll build upon, and I'll sort of add more options to it. So I'm just going to paste a spec which is with a container and 3 replicas to create our deployment, with the image pod info, which is pretty commonly used for a demonstration by Stefan Prodan, and we just use npm sort of npm run build to build the code. So next I'm going to do a CDK synth. But before we do that, let's look at the dist directory which will actually generate our YAML. So right now it's empty, but before we do CDK synth, we need to do an npm run build. So I'll do that, and that should give us the YAML. It runs some tests as well, and this is expected. It fails when we run the test using some of the checks within the test, but we can delete that. But what we can see here is the YAML has been created. So within a few lines of code that we presented, CDK has created the YAML. I'm just removing the test so it doesn't give us any more errors from our package.json. Okay, so yeah, here we are with the deployment, and that's worked fine. We've removed the test, and what I would like to do is actually add a service as well. So we'll pull in the service construct from Kubernetes that we've imported, the JS, which comes by default. You can also import any other constructs you want, but in this case we'll stick to the standard Kubernetes constructs and use and create a spec around the service. And again, I'm going to just create a load balancer, which is going to provision a classic load balancer, in this case on port 80. And use the target port for a deployment, which is I think 9898. And then we can specify the selector, which is the label. So now when we run npm run build, it should provide us with the updated YAML, which includes both the service and the deployment types, and we can go ahead and run or add it using kubectl or kubectl and apply it to our cluster. Just to verify that we are using the same cluster that we created, I'm just going to do a get nodes. It shows 1.18 again, and checking the config, current context, it's the cluster we provisioned. So I'm going to go ahead and apply the definition, and that's created a service and the deployment. So we have the service created and with three replicas, and I'm going to go into the console and look at the load balancer within the EC2 service, and it shows us the DNS name that we can pull out and see that it is up and running. So pod info is presented to us, and we can go ahead and use the app. So this is a really simple example of deployment and a service using CDKs. Right, so let's look into CDKs Plus, which is kind of a follow-up release to CDKs, and it was following the launch of CDKs in May. Elad and Eli launched CDKs Plus in July as a package within CDKs repository to enable higher level constructs. CDKs Plus is a library built on top of CDKs, and it's a rich intent-based class library for using the core Kubernetes API. It includes handcrafted constructs that map to native Kubernetes objects and exposes a richer API with reduced complexity. We'll take a look at how, within the context of what we just demoed, to show how this helps within a simple app that we created. You can head over to our GitHub repository and try it out, and you'll also find documentation for all the available constructs as well as a full API spec. And we'd love to hear what you think is missing, and if you can actively participate in development, you can add your own ideas and help the community. So without waiting any further, let's take a look at CDKs Plus in action. So in this case, in this demo, we'll use that CDKs app we created, but change it to use the CDKs Plus constructs. Okay, so we're back in VS Code, and I'm going to, I think I can check the package.json, and it actually does install CDKs Plus by default when you do a CDKs init. So we don't really need to install CDKs Plus here now. But what we can do is remove the references or the constructs which we pulled from Kubernetes, but import K Plus from CDKs Plus library. And having commented out the previous code, I'm going to create a new deployment using CDKs Plus. And in this case, I'm creating a deployment with a much simpler definitions or props around the deployment. So what we have gone and done is make it more relevant for developers, so that when they are building deployments, they don't have to worry about some of the details that goes into the normal Kubernetes YAML. In this case, you can see I'm just adding a container reference, container prop, and it has just a quick reference to the image we want to use. In this case, we are going to use the same image, and we're going to use the same port. So that's our deployment, and I think I'm following a newer library than before, and that's why it's giving me those highlights within the code. But let's carry on. And when I expose this, this is a much simpler interface to create the service. So deploy.expose at 80, and that is kind of a wrapper around the service, the service construct which we used previously. So here we just specify the service type as a load balancer, and this is it. So all the boilerplate for YAML which needs to be created is created using simple few lines. So it's, for a developer, this is much easier. Now I'm going to troubleshoot the errors I'm getting, as in the highlights in the code. It seems like I'm running an older version of CDK Plus. So in the package.json, I mean, this is a good exercise for you when you're dealing with CDK Plus or CDKs, because they are in alpha. So I'm going to install the latest CDK Plus version, and for a good measure, so here you can see it's updated the CDK Plus version to 0.32, but CDK is 0.30. So update CDK to 0.30 as well, 0.32, sorry. And yeah, I think I'll have to go ahead and remove my node modules directory and reinstall the node packages, npm install. So that's what I'm doing now. So that updates my packages to the latest version, which I have updated in package.json. So there you go. It has updated my YAML, and sorry, so it has updated my node modules, and now I can go ahead and delete the YAML that was generated previously, and follow the steps which we are used to by now, which is npm run build, and that should compile the code, and then we'll look at the dist folder with the YAML, and that's created the service and the deployment. So that's CDK Plus, which simplifies the constructs. Okay, so now using what we have, so we created a CDK EKS app, which helped us create an EKS cluster using the EKS library. But then separately, we created a CDK app, which using the CDK Plus, we created a service deployment, a service which is exposed on port 80. So how about using using that chart within the code of CDK? So right within one piece of code, you can have the chart that was created using CDKs, but you are using your CDK, more familiar CDK constructs, so keeping it all within one piece of code. So let's jump right in. Okay, so we are still within CDK's app, but what we'll do now is move into the CDK EKS app. But before we do that, we want to really use all the code that we have from the CDKs, except the app constructs, which are not needed. So we don't need to initialize the app. We can copy that into the lib folder as a new file, and I'm going to name it as my chart. So file and name it as mychart.js for TypeScript and paste it there. And because we are not using the app construct, we'll just remove it. And there we have it, like just within one piece of code, like we have merged the two codes that we created, and now we want to pull that into our main code, which is for the CDK. So import CDKs from CDKs and import CDKs plus or my chart from my chart. So that allows us to pull in the chart that we created and reference it in this piece of code. So we're going to add this function, which is a unique feature which we've added recently to add CDK's chart. We name it my chart and then create a new instance for the chart as a new CDK's app. So we initialize that and then pass it to my chart with the name my chart. So this is it. So this is a one-liner which allows you to add the chart that you have created for your application into the cluster. And this is great because you can go ahead and define your application within the cluster separately, and then using a single piece of code you can just add it to your cluster. So a single piece of code to maintain and manage for your application and build it from scratch. So I'm sure we're sure that the developers would love this experience when they are both managing creation of clusters and the code, or the teams who are separate creating EKS clusters and building applications within EKS or Kubernetes. They can work together using a single piece of code. So here I'm just following the experience we have seen before around npm run build and making sure we are in the same cluster. And deploying that to our cluster. All right, so whilst this is building, I'm going to take a look at the console, and we don't have any load balancers created yet, but using this time, I'm going to look at one of the new features which was announced around importing Helm charts within the Kubernetes construct. So this was a new feature recently by Matthew Boneg, and that was merged by Elad. So if you are to review any new features, this is a good place to start in terms of the Helm chart which was added, and this is how you can go about understanding what went into that change. So that's a pull request that Matthew created, and that enables the CDKs to use Helm charts as an input. To find out more, I'm just going to go in and look at some of the docs around it. Going into the CDKs GitHub, we have examples directory, and that should provide you with some examples to play around with and create some of the code around custom resource definitions and ingress and pod info, which is one of the examples I'm using right now. So yeah, but to dive deep and understand more, let's go to the website cdk.io, and the docs, which are pretty comprehensive. So that has the new feature added to there, and there you go. So this is a new feature in terms of adding Helm charts to CDKs. That's something you can try out. Okay, so we'll refresh, and hopefully we should have the load balancer created by the code, and we go ahead and take a look at that, and it has the app up and running as we intended. So we can go ahead and follow the workflow around creating a branch with all the updates that we have added. In this case, we have added a CDK's chart to our code, and we can follow the usual sort of Git workflows and GitHub workflows around managing our code and updates to that main piece. So hopefully this provides you with an overview around what is the value that CDKs Plus provides you in terms of managing your EKS clusters and the workflows. So you can go ahead and use this repository as a reference to learn and use the documentation, but I'm just showcasing how you can have a workflow around this. So hope this is useful. So we are nearing to the closure of this tech talk, but before we do that, a few features around importing specific Kubernetes versions into CDKs. That's the command that you'd use, CDKs import and Kubernetes version you're interested in, or setting a API version for a specific object, or using a custom resource definitions. So easily add CRDs to your library which are outside of Kubernetes. So so custom CRDs, you can add those to CDKs as well. Things to know before you can. The CDK and CDKs project are in alpha and constantly going through a feature release cycle and updates. So keep an eye out on the repository, and it's built for entire community. So it can work with any cluster anywhere in terms of Kubernetes, and we are adding more support to different languages. We just added support for Java, but have plans for Go and .NET. So we'd love your contributions. So open an issue or a pull request at AWS Labs CDKs on GitHub. And to recap quickly what we went through, we looked at AWS CDK, CDKs Plus, and how they can be used in conjunction to manage your Kubernetes and EKS workflows. So feel free to contribute. Take a look at the repository and the project, and here are some resources which would help you understand these projects. So feel free to connect. Before we close, I'd like to thank Elad and Nathan for their vision and contribution towards the CDK and CDKs projects, and our fellow developer advocates Pahud and Adam, who have great content around EKS and CDK in general. So do follow them on Twitter and ask any questions to me or them, and we'd be happy to answer any questions you have. But right now we can open up for Q&A, and thank you very much for attending this webinar. So hope you found it useful, and I'll open up to questions. Thank you.